Okay, cool. So thanks everyone for joining us. I'm Michael from the Data Incubator. I think if you've been to a few of these before, you've probably seen me previously. So I'm the founder of the Data Incubator. We started this about a little over 2 years ago as a free fellowship for PhDs and now masters to attend the program. And our deadline is for the next application round is actually coming up. So we will be, so if you're interested, actually you should go to the dataincubator.com and go to /fellowships, I think, and apply from there. But in the meantime, we actually have a small, short program for you, which is maybe a little bit like what we'd be doing in the fellowship. It's called Data Science in 30 Minutes. We will find something interesting to talk about in data science. And we're going to try to stick to our time budget of 30 minutes. So for those of you who haven't done so already, there is a GitHub associated with this. You can follow along the code there by going to the Eventbrite page where you signed up, and there's a link to the GitHub at the bottom, and I think there's also a link in the confirmation email you would have received. And now with me today is Isaiah Yu. So we're changing the format a little bit. So Isaiah is a data scientist and software engineer at Truveris, and perhaps more importantly, a former fellow at the Data Incubator. So say hi, Isaiah. Wave.
Oh. Hi everyone. It's great to be here to talk with you guys. As Michael mentioned, I was a former fellow of Data Incubator. I was part of the class that was here January, February last year. Yeah, now I'm employed at Truveris, which is the authority on prescription benefits, as a data scientist software engineer.
Cool. So I think without further ado, I will let Isaiah take it away from his presentation. But again, just for those of you who just signed in, we have a GitHub available that you can go to. It's available at from the Eventbrite page, and I will also try to send out a link to it in the comment section. So Isaiah, do you want to take it from here?
Sure. So today I'm going to be talking about an algorithm called Holt-Winters, and I want to show how this can be used to forecast time series. So I'm going to spend about 15 minutes just talking about the algorithm and the background theory. And then the next 15 minutes, I'll talk about some applications to it. So let's start on the theory. So the simplest case is when you have a time series that has no trend or seasonality. It's basically flat with random fluctuations up and down. For this case, you want to use something called Holt-Winters single exponential smoothing. So let me talk about this. You guys can see the equation here, one equation. Let me talk about what these things mean. Okay. So xi is the actual value at time I. The index is an index for the time series. Xi is the actual original raw data point. Alpha is a parameter. It's called the mixing parameter. It shows up here, as you can see in the equation, and also okay. There's alpha and also alpha here. Alpha is a mixing parameter. It ranges from 0 to 1. So what is alpha? Alpha is basically how much new versus old information you want to use. Xi, we're currently at step Xi, and that's the most new information we have at this point. And we have this weight alpha. And you have 1 minus alpha for Xi minus 1. This represents the smooth point one time interval before the present. So it's weighting. For example, if you were to set alpha equals to 1, this guy here would just be xi, and the second term would be 0, which means that all we're doing is just, there's no smoothing happening, it's just, all we have is just original data. But if you make alpha less than 1, we also incorporate effects from earlier on in the time series. So you can see that this equation here is a recursion because of this this index, which is lagged. So what would happen if you were to expand this relation, recursion relation? If you do that, you end up with this guy at the bottom. Here, it's summation. As you can see, this is actually exponential. So points that are later on in time series get higher exponents of the coefficient, and as you go closer to the starting time, you get less greater and greater exponent of the weight, which means that there's an exponential decay as you go farther from the present time. Hence the term exponential in the exponential smoothing. So the question is, how would you use this to forecast? So there's a rule. The rule is right here, and the rule is actually kind of dumb. It's actually very simple. So if you want to forecast, say, h steps ahead beyond the last data point, you just make it equal to the last smoothed value in the series. That's all you do. So if you were to plot it out, the forecasted points would just be a horizontal line, which is pretty simple and I guess maybe not that useful. But this is the simplest case of Holt-Winters exponential smoothing. So let's kind of up the complexity and pretend that we have a time series with a trend. This means that there's movement in time series either up or down. In this case, we're going to use something called Holt-Winters double exponential smoothing. The equations are here. This time we have not only an equation for the data points, but also an equation for the trend, which is the second equation. You can see that the equation for the trend has similar form to the original equation, or just the data points. So what do I mean by trend? You can see in this note right here, at time I, Ti is a trend at time I. The trend is defined to be the difference between subsequent values in the series. That's what we call the trend. And we also have another mixing parameter, beta. Beta is the mixing parameter for the trend. It tells us how much new versus old trend information to include. So for example, if you're to make beta equals to 1, the trend at the last or latest points will just be equal to the difference in the most recent data points. And there'd be nothing for the second term. So we would have no weight for the previous trends early on in the series. To forecast a series with double exponential smoothing, the rule is here. In this case, if you want to forecast out h steps ahead or beyond the last points, what we do is we take the last smooth value and then we add basically a linear trend to it. H is the number of steps and Ti is the slope. Ti is the last value in the series for the trend. It's a slope basically. So if you were to plot the forecast along with the original data points, you'd see a straight line with a slope that equals to the smooth trend for the last points in the series. Finally, we have triple exponential smoothing. This is even higher in complexity. This is for the case when we have a seasonal pattern in our data. So we could have both trend and seasonality, and the triple exponential smoothing will take care of it. As you can see, there's an equation for the values in the series with its associated mixing parameter alpha. We also have an equation for the trend, which is the second equation. And note that the second equation here is identical to the second equation in the previous case over here. So these are the same. And finally, we have an extra equation for the seasonality, which is at the bottom. And we have a new mixing parameter gamma, which is for the seasonality. So you also want to include the periodicity or the length of the period, and that's going to be here k. So k is length of the period. So when you look at these equations, these three equations, when you just look at it, your eyes might glaze over, and you might be like, okay, that's might look too complicated, but it's actually not. The way you want to think about this is you want to view SI and TI as so-called doubly smooth values. That is, you want to regard SI and TI as the smooth values that you would get if there were no seasonality. So you could pretend that the seasonality is not taken into account, and you do the double smoothing, and you would get SI and TI for there. On top of that, you'll add the seasonal part, which is from PI. So how would you forecast in this case? In this case, the forecasting rule is at the bottom. If you want to forecast 8 steps ahead, you have the smooth point for the end of the series, plus the linear trend part as before, and also we have this seasonal part at the end right here. As you can see, it's the seasonal part is going to be for I, which is the last point in the series, plus how many steps ahead you want to go, and minus the number of points in the period, which is k. Okay, so that's basically it for the theory. One reason I like Holt-Winters is because you could actually explain it in 15 minutes, and it's a straightforward algorithm you can understand, and something you can use really quickly. Surprisingly, I actually couldn't find an implementation of Holt-Winters in the standard Python packages that data scientists use. But thankfully, there was a really neat Python implementation by some guy named Andre Quiroz. I hope I'm pronouncing his name right. And I put a link in the this presentation for you to be able to see this this file. So let me just go over the functions that are provided in this implementation. There's a function for the doubly smooth values, and that's given by linear. So let me very quickly explain the arguments because I'm going to use this shortly. X is going to be the original time series that you have. FC is going to be the number of points that you want to forecast. How many points out do you want to forecast? So if you want to forecast 3 beyond the last data point, you put in 3. Alpha is going to be the smoothing parameter for the values, and beta is going to be the smoothing parameter for the trend. Next, we have triple exponential smoothing, which is additive. Additive means that the amplitude of the seasonal part is not changing, as opposed to multiplicative, where you'll have a changing amplitude as you go along in the series. So in the triple exponential smoothing, we have X, which is your original series like before. We have M, which is going to be your the length of the period. FC, like before, is number of points beyond last point that you want to forecast. And alpha, beta, and gamma are the mixing parameters for the value, the trend, and the seasonality, respectively. So that's basically it for the functions. Oh, we have multiplicative, which is the same as this guy, but with the multiplicative case, which I don't really talk about, but it's basically the same thing. So let's now move on to the applications. Hey, Michael, how are we on time?
We're doing well, 15 minutes.
Great, nice. So I have 2 applications. The first application is with the double exponential smoothing. So let me just let me load up the Python notebook. So let me import the packages. So this is something I did at Truveris as part of our product called NDI. So what I did here was I took the uninsured, percent uninsured in the nation which is data that you can obtain from the CDC and HIS. You can just get it on the internet. And I took that data, which is quarterly, and I used Holt-Winters to forecast a couple months beyond the most recently available data. So first, I import the data, the CSV. And next, I basically run the Holt-Winters algorithm, and this is in this cell. So one thing I want to note is you have a choice when you use this Holt-Winters algorithm. You can either let the algorithm optimize for you. That is, it'll take your original data and fit the Holt-Winters algorithm in such a way to minimize the error, or you could put the parameters in by hand. What's really cool about this implementation by Andre is that if you don't supply the mixing parameters, it will automatically do an optimization for you and spit out the appropriate parameters, which is really cool. So that's what I do here. Here I don't specify the mixing parameters, alpha or beta. And so what the algorithm does is it actually does the optimization. I believe it uses BFGS optimization. And so you run it, and this is what you get. I actually already have it run, so you can see the plot. But let me just do it again. There we go. So the red points are the original data, and the blue points are the forecast. This is an optimized forecast using Holt-Winters.
And do you have any sense of when Obamacare came out in this time, in this graph of yours?
Yeah, so that's a great question, Michael. As you can see, one thing I should have done in the notebook is actually put times there, which I didn't, unfortunately. But each of these dots is a quarter. So this first 4 points are for 2013. The second set is for 2014, and this third set is for 2015. You can see there's a pretty drastic drop, right? Mm-hmm. For 2013, it's more or less flat, around 14 or 15%. But because of ACA, Obamacare, you see this this pretty drastic decline. And this last points here are the forecast for going into 2016. Ooh. So one thing you want to ask yourself when doing forecasting in this context, for example, is do you really want to optimize over the whole data set? Or is it better to do some, is it better to set the parameters intuitively? In my opinion, in this case, you probably don't want to do an optimization. We probably want to set it by hand because the effect of Obamacare or ACA is probably not going to be persistent. It's probably going to have a big effect for part of the time, but at some point we expect the effects of it to bottom out and flatten. And you could argue that for these points here, it might have right here around 9, 10, 11, you could argue that maybe it flattened out. So with this in mind, I want to show you the application using not the optimization, but tuning parameters by hand. So in this case, I have values here for alpha and beta. Recall that alpha is the smoothing parameter for the values, and beta is a smoothing parameter for the trend. So I set it pretty close to 1 for each of them, which means that newer points, more recent points, get weighted more. So when we do this, we get the plot down here. Let me just run it again. So let me just show you what happens if I were to mess with these parameters. Suppose I make alpha exactly 1 and beta exactly 1 too. Let's see what happens. If we do that, we get this right here. As you can see, the slope for the forecasted part is identical to the slope for the last 2 points, which is expected because there's no weighting for the older points. Likewise, the points are very close to the last point because there's no weighting for the older points. Now let's see the other extreme where we make them close to 0. So let's make it like 0.1, say, and see what happens. If we do that, this is what we get. As you can see, there's a much higher weighting for the older points. This is why it's so high up. And the slope is also more representative of the slopes that were earlier on in the series. For the case at hand with the uninsured rate in the nation, I think probably it's more appropriate to make these closer to 1 because there's a decent likelihood that effects from ACA have flattened out because we already had 2 years of strong effects from it. Let me make that back to what it was. I think it was 0.8, 0.85. I forgot. So this is, this is what I like. So this is the first example. The second example is using triple exponential smoothing. In this case, we're going to look at drug prices. So something I do at work at Truveris is I look at how much it costs on average for drugs, for just say brand drugs. So the way we get these values is we take a weighted average basically. So we take the prices of all brand drugs and we weight them according to how widely they're used. So for example, common painkiller like acetaminophen will get a pretty high weight because it's so commonly used, whereas a drug that's used for a rare disease will have only a couple of people using it, which will give it a lesser weight. So we have this weighted average for brand drugs, and that's the data that you're seeing right here. This is for the years 2013, 2014, and 2015. So it's sort of a line, but if you look closely, you might notice a little bit of curvature, which is sort of expected because when it comes to any sort of prices in the economy, we expect some sort of inflation, right? And inflation, as you guys know, has a sort of exponential pattern. So to kind of strain this out, what I did was I first transformed it by taking the logarithm. So that's what I do here. I take a logarithm. Oh, highlight it? Okay. So I highlight it right here. So here I take the log and I use the NumPy function, the logarithm, and P is for NumPy. And I also do a linear regression. So I use sklearn. They have a class called linear regression in there, which is pretty nice and pretty straightforward to use. So I do linear regression to fit that logged series, and this is what it looks like right here. So obviously the thick blue line is the model, linear model, and you have the original data below it. As you can see, it's pretty close to linear, which justifies my taking the log. So what I now do is I take through what's called a residual. So what is a residual? Residual is when you take your original data and subtract the model. So just a pro tip for people who are aspiring to go into data science is if you want to have an idea, if you want to test how good your model is, you want to look at the residuals. If you take your residuals, and a good idea is to plot the histogram. If you have a histogram that's pretty close to normal, around 0, then the model is probably decent. But if your histogram of the residuals is like lopsided or crooked or something, then your model is probably not very good. So that's just a good way to test one test to see how good the model is. Of course, you also want to look at the errors, but that's also important. So what I do now is I take the residuals, and what's surprising is that if you take the residuals, you actually get a seasonal pattern, which is actually pretty cool. So this is a plot of the residuals. I was not anticipating this when I first did it, but there's actually a recognizable pattern here. So this is for 2013. This is for 2014 and 2015. As you can see, it starts higher up in the beginning of the year and kind of seesaws down towards the end of the year. This, as you can see, it's a pretty good test case for using our Holt-Winters triple exponential smoothing because of the seasonal pattern. So let's see what happens when we do that. In this case, obviously the period for the seasonality is 12 months. 12. So that's where I said here in this Holt-Winters function. So this is the original data. And this is the seasonality, and this is the how far ahead I want to forecast. So I put that in, and then I run it, and I get this thing at the bottom. So the red line is the original data, and the dotted blue line is the forecast. Just for comparison, I did a forecast for 2015, together with a forecast that goes beyond into 2016. As you can see, the model is pretty good. There's kind of a interesting discrepancy here. For some reason, it's bigger than usual for this part, but for the most part, it's a pretty good fit. So now we put it all together. We combine the residual back with the trend line, with linear trend, and this is what we get. So the red part is the original data, and we have the blue part for the forecast into the year. So practically speaking, what you can do is you could use this blue line to forecast the weighted average for brand drugs for some month in 2016. And if you want to look at the error, I took the error for the overlap of 12 months, and we get an error of about 2.3, or a fractional error of about 0.7, which is pretty good. And that is basically it for what I have to say.
Cool. All right, thank you so much, Isaiah. And thanks to everyone who's been attending. I think at this point, we're going to open it up to Q&A. So if you click on the Q&A button on the, well, on my screen, it's going to be on the sort of left-hand panel. If you move your mouse there, something pops out that says Q&A. You can start asking us questions, and we're happy to take questions either about the content, what Isaiah was talking about the fellowship that we run. For those of you who are a few minutes late, it's a free fellowship for PhDs and master's students who are looking to transition into data science, or people who might be interested in our corporate training offerings. If you are interested, if you are sort of at a company and you're looking to get some of the folks at your company skilled up on the techniques like this that we teach at the Data Incubator, you can also feel free to ask questions about that. And of course, this IPython notebook is available on our GitHub, which you can sort of go to. You can search for either on Google. You can look for data science, or the Data Incubator GitHub, or you can go to the Eventbrite for this page, and there's a link to our GitHub there. So I hope people have been able to find the Q&A button and are sort of asking questions there, but I see some questions here have already popped up. First question is Python 3 versus Python 2. Are you using Python 2 or Python 3 for this?
Python 2.7. So my company uses Python for its products. All our product infrastructure and everything is written in Python, except for our mobile and website apps. But we use Python 2. As far as I can tell, I don't know that many people use Python 3. It doesn't seem to have that wide adoption yet for some reason. I don't know.
Yeah, why. I also have not found that many people who've adopted Python 3.
It's supposed to be better, right?
Yeah, we all go around saying it's better, we should update. Yet none of us seem to. We're all sort of secretly guilty of committing some sort of technical debt sin that we don't know about.
Yeah, I think at my company, I think one of the reasons we don't do it is because we have to go back and change so many things if we wanted to adopt it, and that leads us a lot of work.
Yeah, absolutely. And actually, let me just jump on that and ask you another question. What other sort of tools or have you learned, or have you started using since you've joined? And do you think that was sort of reflected in what you learned while you were at the Data Incubator?
I think for sure, just a lot of so just a bit of my background, I went to grad school and got my PhD in theoretical physics. I actually didn't have a strong data or computer science background. So going to the Data Incubator really helped me to learn how to practically navigate data and get useful stuff from it. How to go about using sklearn to make forecasts or predictions, and how to use SQL to mine large data sets, just stuff like that. I think it provided me with a strong toolkit that I could use immediately when I joined my company.
Okay, cool. And are there any specific, thank you very much for the plug, by the way.
Yeah.
But are there any specific tools that you sort of picked up or used? You mentioned Holt-Winters in this one, but
yes. So I think I got some exposure to time series at the fellowship. Another thing that was very useful is the cloud, the whole cloud computing thing. So that's something valuable that would be hard to get if you're just studying data science by yourself. But one thing that I found very valuable about the fellowship was that they provided AWS instances for every participant that enabled us to use Amazon for cloud computing, EC2, and that was really cool and the kind of experience that you can't find in a lot of places.
cool,
Yeah.
cool. Well, thank you again for the plug.
Yeah.
I have another question now. This is a question about modeling, and it's basically well, the way it's phrased is, do industry partners prefer simpler and more robust models, or sort of more complex models? So I guess, you know, you did something that was fairly straightforward in terms of the modeling spectrum, but maybe is a little less accurate. And we can compare that to something like a neural net or a random forest or something that may be a bit more accurate, but maybe a little less robust.
Right.
Well, what's been your experience?
So for me personally, it depends on the project. It really depends on the business goals. I think if you're talking about business, I guess it depends on what you're looking for. I think at least for my company, my industry, they favor maintenance, maintainability, and robustness. The thing about more complex models is that they require a decent amount of maintenance. And so if you build this model and it has high degree of accuracy, that's great. But the question is there someone around to maintain it and to make sure it works? On the other hand, it could take quite a while to build a more complex model. And when you're in a business context, you might want something that's quicker, that can give quicker answers. So it really depends.
Yeah,
yeah.
I think I agree with that, really. I think that there is this sexiness about having the latest and hottest and best model, but ultimately there's nothing like getting stuff done.
Right, practicality.
Practicality. And also just thinking about the maintenance costs, right? Because you're not just building something for today, but you're building something that has to run in a production pipeline day in and day out for months and maybe years to come. And you just want this thing to work so you can build the next thing and not have to come back to this a week from now.
Exactly. So I hear this not only from, this is not only true of me, but also of my friends who are in the industry. So we all want to use the newest tools and the newest algorithms, but it often just isn't very practical.
Yeah, absolutely. Okay, so the two questions have come up, which are more about the fellowship, so I'll just take them really quickly. One is about whether or not international students are allowed to apply. And the answer is actually absolutely yes. I think there were even a number of international students in your class who were accepted. So there's absolutely, if you're an international student and you're interested in applying for the fellowship, we highly encourage you to do so. The second question was really about people with PhDs, without PhDs. What if you got a PhD a number of years ago? And I say, again, all those are open. So it's for people who have or are about to obtain a master's degree, or people who have or are about to obtain a PhD. And have can mean you obtained the degree a year ago, 5 years ago, 10 years ago. We've actually had people sort of with quite a large degree of experience or large range of experiences apply and successfully become fellows. Also, somebody actually is an advocate for Python 3.5. Apparently, at is now a operator in Python 3.5, and it's better than writing np dot.
Wow, that's great.
That's crazy. I didn't even know that at could be an operator in Python, but that's really wonderful. Thank you for including that little bit. So then now, I guess this question is sort of similar to the last one. Holt-Winters versus some other method. I guess we talked about sort of complex methods or simple methods, but what do you see are the advantages of using Holt-Winters versus some others?
So I guess when it comes to time series, there's probably two big forecasting methods. The first one is what I just presented, Holt-Winters. The other one is probably ARMA, autoregressive moving averages, and there's basically textbooks on this. This was mathematics that's widely used by econometricians and also people who are into the stock market. So one reason I like Holt-Winters is because you could do it like very quickly, and it's it's less heavy machinery, and you could just get a quick forecast. ARMA would give you more realistic, more cooler results, more accurate, but there's a much higher learning curve to learn it, and it's heavy machinery, so it'll take longer to work with it. There are packages out there that will do it automatically for you, optimize very well, but it's hard to know what's going on under the hood.
All right, so another question, I think I'll let you answer this first. It's a partisan question.
Okay.
What programming language is best for data science?
I guess for me, well, there's really only two that I know of, Python and R. Those seem to be the dominant ones. I started out using Python, so I guess I kind of stuck with it. I also use some R at work, but I think Python is more suitable to me because I'm also a software engineer, and R is not as good for building out production software. That's kind of a personal bias.
Actually, why don't you say a little bit more about that? So, as I understand, you started off originally sort of as a data scientist,
yeah,
and now you've actually transitioned within the same company, within Truveris, into a more product and kind of engineering role.
Yeah.
Why don't you say a little bit about that transition, why you did it, what the differences are, so people can understand a bit more about that?
Yeah, sure. So after graduating from, after finishing up the Data Incubator, I started out at Truveris in the product development team as a data scientist. That role was more geared towards coming with ideas for products and building out simple prototypes and maintaining existing products. It was sort of more geared towards business. You're closer to clients and talking with them more. Even when I was on the product development team, I was doing quite a lot of coding, both in R and Python, and so I kind of wanted to explore what it was like to be on the engineering team where they do a lot more coding and deal with like more databases and deal with AWS and the whole production. I want to see the whole production side of our company, so that's why I made the move to the engineering team.
Cool. Let's see. The next question is, I think, more Data Incubator specific, but maybe sure, you can jump in a little.
Okay.
Why don't you say a little bit about your level of experience? And specifically, I think they were talking about things with tools like SQL, machine learning, things like that.
Sure.
How much you think you had coming in
right.
as a fellow? And so.
Yeah. So the thing with me is I come from a theoretical physics background. So my PhD was in theory of theoretical physics. My thesis was almost like applied math. I used mathematical software like Mathematica, but I didn't deal with data. I dealt with more pure math like group theory and differential equations and differential geometry, stuff like that. So upon finishing grad school, I had little experience in dealing with in computer science and data, and that's why I applied to the Data Incubator. And going to the Data Incubator helped me to bridge that gap. Of course, before the incubator, I spent all the time on my own just studying stuff like SQL, Python, and machine learning, and programming and statistics.
I think what you're saying is that you don't necessarily need a background, but you do need to put some effort into learning stuff.
Yeah, I think it's important to have to be able to think quantitatively and to think scientifically. But in terms of like if you have experience doing scientific research or engineering or whatever, I think it's not too big of a gap to bridge.
Cool. Yeah, and I would actually absolutely second that. You know, when we look at candidates, we don't necessarily look for formal training. We don't really care what your degree is, whether or not you have a PhD, your race, what city you're from, all those factors that are basically irrelevant in the hiring process. What we really care about is your ability to actually do things, and that can be formally learned, or that can be informally sort of self-taught. And it doesn't matter, because what matters is your ability to produce that. So here's another question for you. Thanks so much for the presentation. Do you work closely with decision makers in your business, like the CEO, people like that, as a data scientist?
Absolutely.
Why don't you talk a bit more about that?
So my company is a late stage startup. So basically,
How many employees?
so we're growing very rapidly, but at last count, it was around maybe between 80 and 90. But I think there's been maybe twofold growth over the past like 1 or 2 years. So basically, when I first started out in our old office, the founder of the company, his name is AJ Lacano. He's also the CIO. Great guy. He basically was like just a couple of seats away from me. He just like walk around the office and talk with everybody, and that's the environment that it was. And he makes, you know, he's the founder. And now my boss right now is the CTO, who basically built out all the products for our company, or at least the first ones, and built out all the architecture for our infrastructure. So yeah, and he basically makes all the decisions that are technical, and I report to him directly.
And do you think that models like this are used and valued on the business side from actually making decisions?
Yes, for sure. I think what Truveris is all about is taking an industry, which is the pharmacy benefits, prescription benefits industry, and bring it into the modern world. So this industry is old and traditional, and not traditionally tech savvy. But the whole what Truveris is about is using technology to improve this industry and this space.
Cool. All right, another question, which is just about applications and when they're due. I actually don't know this off the top of my head, and I'm not going to trust myself to be able to, go research this on our site impromptu. But it's actually easy to look up. You just go to thedataincubator.com and you click under fellowships, and there's a whole section there that's where you can apply for the fellowship and where you can look at what the due date is. So I highly encourage you to do that. I do know it's coming up within a week or so. So if you're looking to apply for the fellowship, you should probably do that and click accept, and sort of put in your name down. You might sort of end up spending the weekend or some part of the weekend working on the application, but it is due shortly. Cool. Great. I think that's about it. I think the questions have. It's actually just a little word of advice. It's actually a little hard to read the questions because all the upvoting and downvoting, they move places every time someone votes. So I think I've gone through and read all the questions. But anyways, this video will stay online for a little bit. If you guys want to read more or learn more about this, it's very easy. You can just go to our YouTube page and we'll have all these videos and the ones from the previous Data Science in 30 Minutes linked and put up online. You can also follow along in the GitHubs for all of those. And if you see anything you'd like to change or edit, feel free to edit that GitHub and submit a pull request. All right. Thanks everyone for joining us, and well, we hope to see you as a fellow shortly. Cheers.